These are going to be a couple of examples to illustrate the difference that you have between the disk washer method versus the shell method. So this problem here says find the volume of the solid generated by revolving the region bounded by x equal to y squared and x equal to 4 about the line x equal to 5. So I have my region drawn there for you. So I have x equal to y squared and then x equal to 4, which is and then the line of revolution that I have out there, which is x equal to 5. So I'm going to do this two different methods just to illustrate the differences that you have. So the first way that I'm going to do this is I'm going to do this with discs or washers. Whichever way you want to think about it, it's basically the same method, just one you have an outer radius and an inner radius, and the other one your inner radius is 0, but either way you're still doing disc and washer method. Alright, so with the disc and washer method, if I want to find the volume of that region there, then my rectangles that I draw need to be perpendicular to my axis of revolution. So if I take my rectangles and I draw these perpendicular to the axis of revolution, then I have my outer radius, which would be here in blue, and I don't have to split this because every one of my rectangles is going to start and stop at the same place. And then I have my inner radius, which I'll draw down here a little bit closer. I have my inner radius, which is there in blue. So on my curve over here, this is the main part to me of doing this, is you have to make sure you label everything correctly. So all these points here, x is equal to y squared, so this is just y squared comma y. And then over here, this is x equal to 5, so this is just 5 comma y there. And then all my points here are on the line where x is equal to 4, so this is 4 comma y, and then again this is still 5 comma y. So once I have that, then I have both of my pieces. I have my outer radius and I have my inner radius. So my outer radius, capital R of y, is going to be the length of those rectangles there, which is going to be 5 minus y squared. And then I have my inner radius, or the smaller of my two radii there. And my inner radius, little r of y, is just going to be 5 minus 4, which is going to be equal to 1. So if I do this with discs and washers, then again, every one of my rectangles, make sure you double check that. Make sure every one of your rectangles that represent your outer radius and your inner radius start and stop at the same place, but they do in that region there, since I have it as x is equal to y squared. But make sure you double check that when you set these up. So doing this with discs and washers, find the volume there. The volume there is going to be pi times the integral. Now I need my bounds. And my bounds, if you come back up here, and I'll put these on there for you, but here, this point here is 4 comma negative 2, and this point here is 4 comma positive 2. And again, you can find those points of intersection very easily by looking up there at your equations that you have. So since we're integrating this with respect to y, because I'm stacking all my rectangles or all my radii, whichever way you want to think about it, I think of them as rectangles, but I'm stacking all my rectangles there horizontally, so I'm integrating everything with respect to y. So if I'm integrating everything with respect to y, I'm going from negative 2 to positive 2 of my outer radius, which was 5 minus y squared, that squared, minus my inner radius, which is 1 squared, and all that dy. For the sake of time, and just to make sure this video will fit on YouTube and different things like that, I'm going to skip a few steps in here in terms of integrating this. So first thing that you have is that you can use some symmetry in the fact that this bottom part down here is equivalent to the top part above the x-axis, so I can use some symmetry. So I can change this as 2 pi times the integral from 0 to 2, just to make the numbers a little bit nicer for myself. And then if you multiply all that out and you combine things, this is what you end up with. You end up with y to the 4th minus 10y squared plus 24, all that dy. And if you go through and you integrate each one of those pieces that you have there and plug in your numbers that you have, what you end up for your final answer, and again, I'll leave that to you because you don't need my help with that part of it, then you end up with 832 pi, all that over 15 for your final answer. Again, I'll leave the integration part to you. That's really not the challenging part of this. The challenging part of any of these problems that you have here in Chapter 7 in our book is the fact that you have to try to get these things set up, and that's the main thing. So again, if you're doing this with the disc or the washer method, you have to make sure that you take your rectangles to be perpendicular to your axis of revolution. So that tells me that I had to integrate everything there with respect to y, because I'm stacking my rectangles, in this case, horizontally. And so everything has to be in terms of y, which it was nice enough to already be in terms of y for me. And then I have to find that outer radius and that inner radius and make sure every one of your rectangles in that region will be able to have the same length. Otherwise, you're going to have to split it into a couple of different pieces. But in that case, I didn't have to do that. They were all going to start and stop in the same location. All right. So give me just a second here while I bring up the other page. So I'm going to start this same problem over, and I'm going to do this with the shell method. All right, so with the shell method, doing the same problem, x equal to y squared, x equal to 4, going to revolve it about the line x equal to 5. If I'm going to do this with the shell method, then the rectangles that I draw have to be parallel to my axis of revolution. So since they have to be parallel to my axis of revolution, then I've got to get everything now in terms of x. So when I draw my rectangles, since I'm doing this with respect to x now, because my rectangles are going to be vertical, I have to get everything up there in terms of x. So what I have is I have that x is equal to y squared. So if I have that x is equal to y squared, that says that y is equal to plus or minus the square root of x. So now I have this in two different pieces, since I have that y equal to positive square root of x and y equal to the negative square root of x. So this top part here that I have, that I'm going to outline in red here, this top part here, that's the positive square root of x, and then my other piece down here that I'm fixing to draw in red as well, that's the negative square root of x. So the main thing to me in doing this is to make sure you label these rectangles and stuff correctly. So here I have my x value, and my y value is the positive square root of x. Down here, my x value is just any old x value, and my y value is the negative square root of x. So the length of those rectangles there, which for me with the shell method is going to be my h of x. My h of x, or the height of those rectangles, or the length of those rectangles, it's a height because it's vertical, but if you have them turned horizontal, then it's still just the length of that rectangle. The length of that rectangle from positive square root of x to negative square root of x, that's going to be 2 square root of x. So that's my h of x. And then I need my p of x. I need the distance that I am from my axis of revolution. So if I take the distance that rectangle, any old rectangle that I have in there, the distance that rectangle is from my axis of revolution, this is just some 5 comma, sorry, not 5 comma x. This is just some 5 comma y value. And here, this is just some x comma some value. I'm only worried about the horizontal distance here, so I don't need the y value there. But the distance that I am from that axis of revolution, p of x, is 5 minus x. Alright, and that's what I need. I need both of those pieces. I need the length of my rectangles, which was 2 square root of x, and I need the distance that I am from my axis of revolution, which I found to be 5 minus x. I need both of those pieces if I'm going to use the shell method. So, I come down here, put all that together with the shell method. So for my shell method, that volume is going to be 2 pi, make sure you get the formula correct, 2 pi times the integral. Now my rectangles are vertical, so I'm going to integrate everything with respect to x. So if I integrate everything with respect to x, my bounds are going to go from 0 to 4. Again, my points of intersection here, my x value is 4, my y value is positive 2 and negative 2 respectively. Okay, so I'm going to integrate from 0 to 4 of h of x, which I found to be 2 square root of x, times p of x, which I found to be 5 minus x. I need both those pieces, all that dx. And again, the integration part is not overly challenging here. But you should get the same answer that we got the other way, and you do. I worked it out. You do get the same answer either way. If you multiply this out, I'll do a couple of steps with you. This becomes 2 pi times the integral from 0 to 4 of 10 times x to the 1/2 power, square root of x to the 1/2 power, minus, and this is 2 times x to the 3/2 power. And then integrate each one of those pieces, plug in your bounds, and I promise you, you can double check me, I'll leave that for you, but you do end up with the same answer of 832 pi, all that over 15. So either technique that you use, whether you use the disk method, shell method, doesn't matter, but just make sure the main thing is that you get those rectangles up there and labeled appropriately. And you got to remember, if you're doing the shell method, they have to be parallel to your axis of revolution. If you're doing the disk method, they have to be perpendicular to your axis of revolution. So that's one example. I'm going to do one more in the next video just to make sure you have a good grasp and some good examples to go by to help you with both of these methods that we're doing here.